Decades following the First World War saw aircraft designers pushing the boundaries of aeronautical technology, moving the industry forward at a rapid pace. With new commercial markets opening up, it was the visionaries who held the keys to success, each invention heralding a future world of unimaginable connection. A Dutch aeroplane designer had the greatest influence on German aviation manufacture in the early years. Born in the Dutch East Indies, Anthony Fokker became fascinated with aviation in 1908, aged 18, when he read about Wilbur Wright's exhibition flights in France. He built his first aircraft 2 years later, and soon set up his own German-based manufacturing company. Known as the Flying Dutchman, Fokker flew as an exhibition pilot and wrote of the daring spirits, ne'er-do-wells and adventurers he encountered on the flying field in the early years of aviation. Then the First World War started, and the German government took over his factory, retaining Fokker as a director and aircraft designer. When French air ace Roland Garros was forced to make an emergency landing behind enemy lines, his monoplane was sent to Fokker's factory, where the designer developed a synchronizer, allowing bullets to be fired between the blades of a moving propeller. The weapon gave Germany the edge in the air war for quite some time, and became known as the Fokker Scourge. After the war, Fokker smuggled hundreds of airframes, engines and parts across the border into Holland, where he set up a new manufacturing plant. His most successful aircraft was the Fokker F7, an 8 to 12-seat airliner that proved very successful for long-distance passenger travel. Built first as a single-engined, high-winged monoplane, Fokker and Dutch airline KLM used the early incarnations of the F7 to test various technologies, such as different engines and new tail fins. Aeroplane manufacture was moving from an era when designers often built their own inventions to a time when the level of complexity required specialist engineers and mechanics. Fokker hired a team of 6 university-educated engineers to redesign the F7 into the best airliner in the world. The team kept the fuselage the same, concentrating on reworking the wings and undercarriage. Bertus Grazé simplified the undercarriage design, attaching just one main strut from each wheel to the main spar. Rubber rings in the main struts absorbed the shock of bouncing across grass airfields. A more rounded, horizontal stabilizer was developed, and the pilot could adjust the stabilizer while in flight, making it much easier to trim the aeroplane correctly. On the 12th of March 1925, the F7A made its first flight, powered by a 420 horsepower Packard Liberty engine. In the weeks following its launch, pilot Grazé set several endurance records. At a public display, he impressed reporters and industry representatives with the ease of his aerobatic maneuvers. One observer wrote, "The aircraft, just like other Fokkers, did not spin or sideslip when stalled, but remained fully controllable, nosed down a bit to pick up speed again, and came back to its normal straight and level flying position. This was demonstrated both with power off and power on. With power on, the aircraft came down like a parachute, nose down, and went into gliding flight." Before long, KLM ordered its first F7, although the airline specified it would provide its own engine to keep costs down. 40 aircraft of the type were built in total, 4 of them by KLM itself, using parts retrieved from written-off aeroplanes. American millionaire Van Leer Black took a KLM flight from Amsterdam to Batavia in an F7 fitted out for luxury travel, especially for him. Extra fuel and oil tanks were added for the long journey, and the aeroplane set out from Amsterdam Schiphol airfield on the 15th of June 1927, arriving in Batavia 10 days later, a 9,000-mile trip. Even with a delay in Allahabad due to lubrication trouble, it was still a world record and became a potent symbol of the possibilities of civil aviation. Black leased 2 KLM Fokker aeroplanes as his private transport and remained a high-profile supporter of flying up to his mysterious death in 1930, when he fell from the deck of his yacht Sabalo in mid-ocean. Licenses to manufacture the F7 were given to factories in 7 countries. And in 1922, Fokker moved to the United States, where he established the Atlantic Aircraft Corporation. While talking to his Dutch-born American employee Robert Nordine, Fokker was given the idea to create a multi-engined version of the popular F7. Nordine later wrote that Fokker at first told him he was crazy when he broached the idea. Nordine replied, "Nobody is crazy enough to fly over mountains in a single-engined aircraft. If the engine fails, you've had it. But when you have 3 engines and 1 fails, you can just go on flying." Fokker was impressed with this reasoning and realized the commercial potential of a tri-motor. As well as becoming a popular choice for emerging airlines from Europe to the United States, the F7 trimotor was flown by many pioneer aviators when they set flying records. Amelia Earhart, Charles Kingsford Smith and Richard Byrd were among the greats who used a Fokker trimotor when they embarked on their risky quests. The Fokker 7 remained a staple of the airline industry until 1931, when a trimotor crashed, killing 8 people, including star football coach Knut Rockne. An investigation revealed that the accident was caused by a structural defect, and all airlines removed the trimotor from service. Fokker concentrated on military aircraft until his premature death at the age of 49 from meningitis. The Fokker 12 was another trimotor created for KLM, with 8 ordered for the Amsterdam-Batavia route. After its first flight in December 1930, the airliner went into service on the 5th of March 1931, taking up to 18 passengers on their 10-day flight to the East Indies in unprecedented comfort. 6 seats could be folded out and used as beds. The 3 456 horsepower Bristol Jupiter radial engines were later replaced with Pratt & Whitney Wasp-C radials. The beautiful 4-engined F-36, dubbed Arendt, was unfortunately superseded by metal airliners soon after its debut in 1934. Powered by 4 Wright Cyclone radial pistol engines, the aeroplane could carry 32 passengers and 4 crew. But as a wood and fabric aeroplane, its era had come to an end, and no more of its type were ever built. The Arendt survived the Spanish Civil War to fly with Scottish Aviation before entering service with the RAF as a wireless and navigator training craft in World War II. A crash landing in 1940 damaged it beyond repair.
I think that's an interesting thing.
This one piece will make 52 layers.
Watch on mobile devices or the big screen. All for free. No subscription required.
French air ace René Fonck was one of the few great fighter pilots to survive World War I. The dashing Frenchman left little to chance, applying mathematical principles to combat flying and developing a thorough appreciation of the engineering specifications behind the aircraft he flew. After the war, Fonck joined with aircraft designer Igor Sikorsky to compete in the Orteig Prize for the first aviators to cross the Atlantic. A Russian-born American, Sikorsky designed his first helicopter in 1909, and his airplanes were used as bombers in the Russian Air Force during World War I. He then moved to the United States and formed the Sikorsky Aero Engineering Company, with financial support from patrons including composer Sergei Rachmaninoff. In 1926, Fonck convinced him to redesign his twin-engined long-range transport plane, the S-35, for a transatlantic crossing. An extra engine was added, and fuel capacity greatly increased. Jettisonable auxiliary landing gear was also fitted in time for takeoff on September the 21st. On board the aeroplane were pilot Fonck, co-pilot Lawrence Curtin, radio operator Charles Clavier, and Sikorsky mechanic Jacob Islamov. No expense was spared, and the team received publicity for the lavishness of their preparations. The New York Times reported on August the 16th, "A hot dinner cooked in New York will be eaten in Paris some 2 days later, it was announced last night, if the plans for the transatlantic non-stop flight of Captain René Fonck, French war ace, and his associates go through as planned. The dinner will be prepared by chefs of the Hotel McAlpin. It will be placed in vacuum containers to keep it as hot as when it came off the ranges, and is to be served at the Hotel Crillon to Robert Jackson, American sponsor of the flight, the aviators and others after the plane's arrival. The menu includes Manhattan clam chowder, Baltimore terrapin, roast Long Island duck, and Vermont turkey." A huge crowd gathered to watch the men embark on what it was hoped would be a record-breaking flight. But as the aeroplane gathered speed on the runway, part of the auxiliary landing gear broke off, and the aircraft spun out of control down a steep slope. Only the 2 pilots survived, and the $100,000 aeroplane was damaged beyond repair. The following year, Charles Lindbergh won the prize. In 1928, the Sikorsky Company was taken over by United Aircraft and became famous for its flying boats such as the S-42. Sikorsky also pursued his interest in helicopters and developed the first American helicopter, the Vought Sikorsky VS-300, which made its inaugural flight in 1939. Even today, the Sikorsky name is synonymous with aviation, and Sikorsky helicopters are in service around the world. Another important aviation company was Junkers & Co., a major German aircraft manufacturer. Founded in 1895 by Hugo Junkers to manufacture boilers and radiators, the company moved into aviation after the First World War and was soon producing passenger planes, including the F-13, the world's first all-metal airliner. In 1929, the Junkers G-38 all-metal airliner made its maiden flight. With a staggering 144-foot wing spread, the 24-ton monster was an impressive example of German engineering. Its predecessors, the Junkers W-33 and W-34, had sold well to airlines and set many records for endurance, distance, and altitude. The G-38 could carry around 30 passengers, and its luxury rivaled the Zeppelin airships. In 1931, it was put into service by German airline Lufthansa between Berlin and London. A second aircraft was flown between Berlin, Hanover, Amsterdam, and London. This G-38 flew for a decade before being converted to a transport craft in World War II. It was destroyed by a bombing raid in 1941. One of the most memorable figures in American aviation was eccentric businessman and airplane designer Howard Hughes. The noted playboy had a string of glamorous Hollywood girlfriends, including Katharine Hepburn and Ava Gardner, and made several successful movies. One of the most expensive was Hell's Angels, a war film focusing on World War I flyers. Hughes set several world speed records, often in aeroplanes of his own design, including the Hughes H-1 Racer. In 1938, he took just 3 days and 19 hours to fly around the world in a Lockheed Super Electra, breaking the previous record by more than 4 days. Unfortunately, not all airplane designers were successful in their endeavors. Ohio-born pilot and designer Leonard Bonney flew exhibition flights for the Wright brothers in the early years of aviation. In 1914, he survived an accident in Pennsylvania when the elevator on his aircraft broke loose, causing the plane to plunge 1,200 feet before crash landing. Miraculously, Bonnie escaped the flames without even a broken bone. Sadly, he was not so lucky during the test flight of his personally designed Bonnie Gull. He tested his design in wind tunnels and was satisfied that it was ready to fly on the 4th of May 1928, despite the protests of family and friends. Bonnie took off, but the Gull wobbled and flailed, plunging into the ground, killing the inventor instantly. Bonnie had begun building the aeroplane in 1925 and designed it with revolutionary duraluminum gull-like folding wings and a side-by-side cockpit. He modeled the aircraft on seagulls, believing that birds held the secret to aerodynamic principles. The angle of the wing could be varied, as could its dihedral and the sweep of the outer sections. Another inventor who was fascinated with birds in flight was Washington-born Lyman Gilmore. The eccentric inventor was well known for his luxuriant long locks and flowing beard, the result of a bet with his brother. Gilmore swore he would not cut his hair or shave his beard until Williams Jennings Bryan was elected president, thus keeping his hirsute appearance until he was 74, upon which it was shaved off on his deathbed by hospital staff. He also wore a trench coat in all weather, claiming it staved off infections. Gilmore's first aircraft was an 18-foot glider he built in the 1890s that flew when towed by a horse. Unfortunately, he had borrowed his employer's horse without asking, and when the glider rose over it, the horse bolted in fright. Gilmore was subsequently fired and moved to Grass Valley, California, where he worked on his next contraption, a 32-foot steam-powered flying machine that Gilmore claimed to have flown in 1902, a year before the Wright brothers' successful flight at Kitty Hawk. However, he had no witnesses to the event, and most people were dubious that the heavy flying machine was capable of leaving the ground. Despite his annoyance at the authorities' refusal to credit him with the first powered flight, Gilmore continued to construct inventions in his Grass Valley workshop, including a monster fuselage. Although he did not go down in the annals of aviation history as the world's first powered flyer, on March the 15th, 1907, Gilmore did open America's first commercial airfield. The following year, Gilmore built two relatively sophisticated flying machines. The small monoplane could only fly in small hops, although some have speculated that a skilled pilot could have coaxed it to cover longer distances. The large aeroplane was a fascinating prototype that foreshadowed the design of later passenger planes. It featured a closed cabin fuselage and weighed more than 1,600 pounds. While there is scant evidence about the actual flights made by Gilmore's aeroplanes, a local newspaper referred to Gilmore as a full-fledged aviator who made a flight without breaking his neck. In the years following the First World War, Gilmore hired barnstormers to stage flying displays at his aerodrome. He displayed his own inventions in the hangars for public exhibition. Sadly, these amazing machines were lost in a 1935 fire that burned the hangars to the ground. While the fire was classified as an accident, there was a rumor that it had been deliberately lit by someone aggrieved that Gilmore had shot his dog. After the fire, Gilmore lost interest in aviation and pursued a mining venture until his death, aged 74. In his will, he requested his executors distribute his estate in such a manner as will promote the knowledge and science of mechanical engineering. Eccentric pilots were popular fodder for the newsreels of the 1920s. This entertaining piece shows pilot Major L.P. Openshaw taking his new bride, Jean, on their honeymoon in a Westland widgeon. The light two-seater monoplane was designed in 1924 in response to a British Air Ministry competition that aimed to encourage the development of cheap private aeroplanes. British manufacturer Westland Aircraft produced two designs for the competition, a biplane and the Widgeon Parasol monoplane. The Widgeon was made from mixed steel tube and wood, with wooden parasol wings that folded for easy storage. Unfortunately, the prototype crashed at the competitive trials due to an underpowered engine. Nevertheless, Westland continued working on the monoplane, adding an Armstrong-Siddeley-Genet engine. During the early years of aviation, competitions were used to stimulate the development of aircraft design. In 1924, the British Air Council offered a prize for the best two-seater airplane. The Parnell Aircraft Company came up with the quirky Pixie 3A, a tiny biplane with foldable wings, powered by a 32-horsepower British Cherub 3 engine. The company also manufactured a monoplane version. However, neither aeroplane performed well in the competition, both being forced down with engine trouble. It wasn't until 1926 that the Pixie 3 redeemed itself, coming fourth in the Lympne trials. Another fast, agile aeroplane was the U-12, designed by Hans Hermann in 1925 for German flyer Ernst Udet's aircraft company. Udet was a German air ace, second only to the Red Baron. Like so many fighter pilots, he struggled to find work after the war, turning to aerobatics, air racing, and aerial film work to make a living. In 1933, Udet brought his U-12B Flamingo Special to the United States, where he performed thrilling stunts in front of huge crowds gathered for the international air races.
I'm glad to be able to fly in Chicago. Of course, it's nothing like flying over Greenland, where I made SOS Iceberg the last year for the Universal Pictures Corporation.
Texan air adventurer Jimmy Weddell preferred a monoplane for his daring feats. Rejected for army flying because he was blind in one eye, Weddell became a gun runner along the Mexican border. When the law caught up with him, Jimmy and his friend Harry Williams set up the Weddell-Williams aviation business. One branch of the business was the manufacture of aeroplanes, including sophisticated racing monoplanes. They tasted their first success with the 44, a pylon racer piloted by Weddell that took out the coveted Alvin Callender trophy.
I'm very proud to win this beautiful trophy that Mr. Phillips put up for this race.
In 1933, Weddell took out a swag of records, including the world speed record. However, the following year he was killed in a crash while giving a flying lesson. The interwar years saw some important innovations in the aviation industry. In 1921, wing walker Wesley May climbed out onto the wing of a Curtiss JN-4 aeroplane with a can of fuel and poured it into the gas tank. While this was more a stunt than a practical refueling option, in 1923, two United States Army Service Airco DH-4B biplanes took part in the first air-to-air refueling. A hose was run down from a handheld fuel tank in one aeroplane into the other aeroplane's fuel filler. A couple of months later, a DH-4B set an endurance record by staying aloft for 37 hours. It was refueled 9 times with 687 gallons of gasoline and 38 gallons of engine oil. In 1929, the Spokane Sun God, a Buell CA-6 Sesquiplane, made the first non-stop transcontinental round-trip flight. A section of its fuselage was removed so the aeroplane could be refueled in mid-flight. Pilots Nick Memmer and Art Walker flew from Spokane, Washington to San Francisco, to New York, then back to Spokane. The pilots endured savage storms, smoke from forest fires, and sheer exhaustion. At one point, refueling gas had to be delivered via milk cans lowered on a sling. After 120 hours, Memmer and Walker finally arrived back at Feltzfield, Spokane, where they were welcomed by a crowd of 10,000 people. The 5-day flight set a world distance record of 7,200 point-to-point miles. Air-to-air refueling was just one option for non-stop flying. Slings that hooked fuel cylinders from the ground were also tested. German designer Alexander Lippisch was noted for his innovative prototypes. His first tailless glider was built in 1921, and Lippisch spent the next decade experimenting and refining a design he christened Storch. The Storch 5 incorporated an 8-horsepower DKW engine and became Lippisch's first powered model. The first public flight was made at Berlin's Tempelhof airfield in October 1929, piloted by Günther Gronhoff. Fellow pilot Helman Kohl saw the demonstration and asked Lippisch to design an aircraft that could be used for transatlantic crossings, leading to the acclaimed Delta series of aeroplanes. The Storch series featured swept-back leading and trailing edges. The Delta series incorporated the swept-back wing, but changed the design of the trailing edge to be a straight line. Lippisch also experimented with rocket power, collaborating with fellow enthusiast Fritz von Opel, an heir to the Opel automobile fortune. Von Opel's love of rockets and his showy demonstrations of rocket-propelled motorcycles had earned him the nickname Rocket Fritz from the international media. Von Opel attached a rocket to a sailplane designed by Lippisch and launched the world's first rocket plane in 1928. The solid rockets did not provide enough thrust and caused an explosion on its second flight, so Von Opel commissioned a new aeroplane from Julius Attry. The Opel Zander REK-1 Attry Flugzeug was to become the world's first purpose-built rocket-powered aircraft. Attry test flew the rocket-propelled glider on the 17th of September 1929, becoming the first pilot to fly a rocket plane. On September the 30th, Von Opel took the glider to an airfield at Frankfurt am Main. Like the previous design, the REK-1 had a sailplane wing. A pod was attached under the wing with room for the pilot and 16 black powder rockets. The tailplane was mounted on booms high on the aircraft to protect it from the rocket exhaust. German pyrotechnics engineer Friedrich Zander supplied the rocket engines. Von Opel had been disappointed not to have a chance to fly his first invention, so he seized the opportunity to pilot the REK-1. He climbed into the cockpit to be launched by a 20-meter-long rail launcher. After 3 attempts, Von Opel got airborne and flew the aircraft 1.5 kilometers in 75 seconds. Unfortunately, the aeroplane landed so hard it was damaged beyond repair. Watching the flight was Von Opel's fiancée, Frau Zelnick, also a pilot. Zelnick had helped with the technical specifications of the project. General Motors, the majority shareholder of the Opel company, then banned further rocket research, and Von Opel left the industry and moved to Switzerland. 1929 was also the year that Gottlob Espenlaub tested his own rocket plane. After several years experimenting with sailplanes and collaborating with Lippisch, Espenlaub had moved into rocket testing, developing the E-13 in 1928. A few weeks after Von Opel's test flight, Espenlaub successfully piloted the purpose-built rocket glider. Its eye-catching streamlined chassis was given added impact by the eyes and teeth painted onto its nose. The aircraft took flight, powered by a rocket burst, and briefly burned before Espenlaub brought it under control and to a safe landing. Soon afterwards, Espenlaub piloted the LF-5 monoplane created by Swiss designer Alexander Soldenhoff. Like all test flights of the era, it was a risky venture. One German newspaper wrote, "Our grandchildren, when they see a museum exhibit entitled Aircraft from the First Half of the 20th Century, will shake their heads at our courage." Powered by a 32 horsepower engine, the LF-5 was able to reach 150 kilometers an hour. With its fast speed and streamlined design, the LF-5 was a little more practical than another experimental airplane of the era, the rubber plane. Its single propeller was precariously mounted on the wing that swayed over a cigar-shaped body containing the tiny cockpit. Experiments such as this foreshadowed the invention of the helicopter. Argentinian Raúl Pescara was the first person to demonstrate that it was possible for a helicopter to reach the ground safely if its engine failed, as air rushing through the propeller could keep it turning, a phenomenon known as autorotation. Of all his prototypes, the number 3 helicopter was the most successful, making 10-minute flights by 1924. It was the first flyable helicopter with collective and cyclic controls. Another helicopter pioneer was Frenchman Etienne Eumichen, whose aircraft set the first helicopter distance record recognized by the Fédération Aéronautique Internationale. He added a balloon to the machine to give the twin-rotor helicopter enough lift to fly. He was also the first to fly 1 kilometer in a closed circuit, a feat that took 14 minutes and elevated him to an altitude of 50 feet. Although helicopter designs were slow to get off the ground, airship technology was going from strength to strength, with the post-war era turning out to be a golden age for Zeppelins. Airship pioneer Count Ferdinand von Zeppelin died in 1917, but the Zeppelin Airship Company continued to manufacture giant airships. It reached the pinnacle in 1928 with the release of LZ-127, also known as Kraft Zeppelin. This colossus of the skies made its first transatlantic passenger flight on October the 11th between Germany and America. The 20 passengers, who included Hearst newspaper reporter Lady Grace Drummond Hay, landed in New Jersey 111 hours and 44 minutes later. The return journey was 71 hours and 49 minutes, half the time it took to cross the Atlantic by ocean liner. Drummond Hay was also aboard the Kraft Zeppelin when it embarked on a historic round-the-world flight in 1929. The only woman in the party, she sent back news reports as the airship flew across the Atlantic to Germany, across Siberia to Tokyo, then the first non-stop flight across the Pacific to Los Angeles. The final leg was a 3-day journey, and the entire trip took 21 days. In future years, the Kraft Zeppelin made an exploratory flight over the Arctic and carried thousands of passengers across the Atlantic. It became the first aircraft to fly more than 1 million miles and had a perfect safety record. The American military also invested in airship technology during the 1920s. The airship Los Angeles was built in Germany as part of a war reparations deal and arrived in the United States in 1924. With its envelope filled with helium rather than hydrogen gas for safety reasons, the USS Los Angeles carried out test flights for the US Navy and tested mooring points on the floating airship base, the Patoka. The dirigible also helped calibrate East Coast radio compasses and made a landing on the aircraft carrier Saratoga. The US Army Corps built its own airships in the 1920s, including TC-3, a non-rigid blimp. In 1924, the TC-3 and a US Army Air Service Sperry Messenger made the first successful airship-aeroplane hookup when the Messenger docked underneath the TC-3. The term blimp was supposedly coined by Lieutenant Cunningham of the Royal British Navy, from the sound made when tapping the balloon with a finger. The Army's tests were successful, but the project was abandoned, with only the Navy pushing forward with construction of rigid airships. Despite the catastrophic failure of airship R-38 during maneuvers in 1921, Britain forged ahead with airship design. The non-rigid AD-1G FAAX was a private vessel built by the Airship Development Company for advertising purposes. After several months of work in an old Army airship hangar, the blimp made its maiden flight in September 1929. Unemployed men were paid to pull the airship in and out of the hangar using ropes, as no steering mast had been built. The first company to avail itself of the advertising opportunity was the Walter Wilson grocery chain. However, the AD-1 had a short life, crashing in Belgium the following year while advertising cigarettes. The pilot was unhurt, the airship damaged beyond repair. It was auctioned in 1931, with the gondola fetching £2 and the 75-horsepower Rolls-Royce engine selling for £13.10. The engine found a new lease of life in a Whitley Bay speedboat. Also in Britain, the R100 series was being developed, with the idea of using rigid airships as passenger and mail carriers from Britain to the far reaches of its empire. The government commissioned the Airship Guarantee Company, a subsidiary of the Vickers Armstrong weapons firm, to build the R100. At the same time, the Air Ministry started work on the R101. The R100 team included aircraft engineer Barnes Wallace and senior stress engineer Neville Shute Norway, later to find fame as the author of adventure novels. Working in the wilds of Yorkshire, the team faced many practical difficulties, from lack of skilled workers to icy cold weather and a limited budget. However, the engineers overcame the problems and came up with ingenious solutions, such as a frame made from only 11 standardized components fitted into a non-rectilinear framework. Wiring was color-coded for the first time. When it became apparent that customized engines would not be built in time, the team decided to fit 6 Rolls-Royce Condor petrol engines despite the increased fire risk. The R101 fitted diesel engines, which were much heavier. The Rolls-Royce engines included 2 with reversing ability to enable precise docking onto a steering mast. The R100 team was surprised to learn that none of the R101 engines had the capacity to reverse. But there were many inconsistencies in the R101 design. The Air Ministry changed the original design from a safety factor of 2 to a safety factor of 3. This strengthened the structural framework while overloading the airship by 20 to 30 tons. While some of the design team's innovations were ingenious, such as ballast operated by a valve system, the Beardmore engine was unsuited to the airship, and the fins, elevators and rudders were poorly designed and difficult to operate. Ultimately, it was overweight, leaky, and short of lift. After the R100 successfully flew to Canada and back in 1930, the pressure was on for the R101 to demonstrate its prowess. Despite its many flaws, the airship was talked up by authorities, including the Secretary of State for Air, Lord Thomson, who said it was safe as a house, and scheduled its maiden voyage for October 1930. Lord Thomson and 53 other officials and crew boarded the airship for the planned flight to India. Sadly, the vessel crashed into a hillside in France during bad weather, killing 47 people, including Thomson. The tragedy marked the end of Britain's airship program, and the R100 was broken down for scrap and sold for less than £600. The US Navy also had its share of airship disasters, with the USS Akron crashing off the New Jersey coast in 1933. The 785-foot helium-filled dirigible was one of the largest flying objects in the world. On April the 3rd, the Akron was caught in wild weather over the Atlantic and sank, killing 73 men. The few survivors were picked up by a German motorboat. The Akron's bent and twisted framework was later salvaged. Its sister ship, the USS Macon, was also lost 2 years later. Fortunately, lessons had been learned from the Akron disaster, and only 2 of the 76 crewmen died thanks to the introduction of life jackets and rafts. Naval airship officer Lieutenant Tex Settle served on several airships during the 1920s and designed a stratospheric balloon attached to a sealed cylinder that he dubbed, with mordant humour, the Flying Coffin. In 1933, the balloon was launched at the Century of Progress exposition in Chicago. Settle, the only man in the world licensed to fly every type of aircraft, took it up in an attempt to set the world altitude record. It was the height of the Great Depression, and tens of thousands of people flocked to Soldier Field to witness the ascension of the 600,000 cubic feet, 105-foot diameter balloon. But trouble struck when the gas release valve failed to work properly. Settle was forced to make a spectacular crash landing on nearby railway tracks, rather than release clouds of hydrogen gas that could have endangered the spectators. Just a few weeks later, the Soviet balloon Stratostrat took out the record. The 1930s saw intense competition between aeroplanes and airships for dominance in the commercial aviation industry. And the Germans were ahead of the field in airship design with their gargantuan transatlantic liners. The mightiest of them all was the Hindenburg, a luxury vessel accommodating up to 50 passengers over 2 decks. On the upper deck, its wealthy passengers could promenade along 2 walkways, gazing out through huge windows at the panorama below. The dining room offered silver service on white linen tablecloths, the lounge held a baby grand piano, and the rather cramped cabins contained 2 berths and a wash basin, similar to Pullman railroad coaches. On the lower deck were bathrooms, a shower, crew quarters, a kitchen, and even a smoking lounge. The largest man-made object ever to take to the skies, the Hindenburg was lifted by hydrogen gas, as an American military embargo prevented the airship from using the less flammable option of helium. However, German airships had been safely using hydrogen for some time, leading many to believe that they had mastered the volatile element. After the first year of service in 1936, during which the Hindenburg crossed the Atlantic 34 times, weight savings, including the removal of the piano, increased passenger capacity to 72. The Hindenburg was seen as a safe, comfortable way to travel, so stable that many passengers were airborne before they even realized they'd taken off. But on May the 6th, 1937, came the event that was to put an end to passenger airship travel forever. It was the 11th time that year that the Hindenburg had approached its docking point at Lakehurst, New Jersey, following a voyage from Europe. In mid-afternoon, the airship glided majestically over New York. After diverting due to electrical storms, the Hindenburg arrived at Lakehurst that evening. It was then that disaster struck. A lick of flame appeared high on the ship, and within seconds the airship had burst into flames. The frame sank to the ground, killing 35 of the 97 people on board. In less than 30 seconds, the great liner of the skies was a charred mass of twisted metal. Cameramen at the scene had stopped filming after they captured footage of the mooring lines being secured, so the actual moment of ignition was not caught on film. But radio reporter Herb Morrison's eyewitness account was heard all around the world.
It burst into flames. Get this started, get this started. It's crashing terrible. Oh my, get out of the way, please. It's burning, bursting into flames, and it's falling on the mooring mast, and all the folks agree that this is terrible. This is one of the worst catastrophes in the world.
The exact cause of the fire remains a mystery. The crew believed it was sabotage from a time bomb set up by people opposed to the Nazi regime. But recent research suggests the sealant used to coat the skin of the airship's gas bag, made up of iron oxide and aluminium powder, was ignited by static electricity generated from the electrical storm. Whatever the cause, the graphic images of the Hindenburg plunging to her doom meant the age of airships was at an end. The other passenger liners were grounded, and aeroplanes took the ascendancy. Throughout the 1920s, designers had been improving aeroplanes. Following on from the giant biplanes flown in the final years of the war, the creation of even more powerful engines meant aeroplanes were growing ever bigger. The largest single-engine aircraft was the British Blackburn Napier Cabarrus, whose wings stretched an impressive 88 feet from end to end. The aeroplane flew a weight of 9 tons thanks to its 1,000 horsepower, 16-cylinder, water-cooled X-type engine. Seen alongside the puny 1909 Antoinette monoplane flown by Hubert Latham, the Blackburn Napier demonstrated just how far aviation had come in less than 20 years. The Royal Air Force used the Cabarrus as a testing craft during the 1920s. The Vickers Vanguard was another giant of the sky, a 23-seat airliner powered by 2 Napier Lion engines. On display at the Hendon Air Show in 1925, it was described as a striking commercial type. The Vickers Company was better known for its military aircraft and weapons manufacture. But the end of the Great War had seen Vickers aircraft playing an important role in civil aviation. It was a Vickers Vimy converted bomber that carried out the first flight from England to Australia, and the Vimy was commissioned as a commercial airliner in 1919. The Vanguard entered service with Imperial Airways in May 1928. A one-off civil variant of a military design, the aircraft became the Type 103 Vanguard when its engines were replaced with 485 kilowatt Rolls-Royce Condor 3 models. Sadly, the Vanguard had a short life, as it was destroyed in late 1928 during testing, following modification of its tail unit. France's Farman Aviation Works also produced a number of big aeroplanes, including the F-180 Oiseau Bleu, a distinctive twin-engined biplane with the capacity to carry 24 passengers. The 2 Farman piston engines were mounted on the upper wing, facing in opposite directions. Its wings spanned a mighty 85 meters. The aeroplane was originally intended to operate non-stop from Paris to New York, but Farman decided to keep its 3 F-180s and used them as company planes for several years. The world's largest monoplane was the Beardmore Inflexible, a revolutionary stressed skin metal aircraft that heralded a new era of aeroplane design. With a wingspan of 157 feet, the mid-wing aeroplane towered over its rivals. But the Beardmore's massive girth was also its downfall, as it was actually too heavy for its 3 Rolls-Royce Condor engines. It took its maiden flight in 1928 in front of a huge crowd at Martlesham Heath airfield. An extra 400 yards of heath was cleared, as it was thought the aeroplane would overrun the existing runway on its takeoff. However, the monoplane took off before the end of the runway and made an uneventful flight. But because it had been fitted with support cables due to concerns that its wings would fold from the weight of the aircraft, it was only ever flown as a display model. In 1930, the Beardmore was pulled to pieces and ended its days as a testing board for corrosion experiments. French engineer René Cousinet's revolutionary monoplane was another aircraft making its maiden flight in 1928. The trimotor Cousinet 10, known as the Arc-en-Ciel, featured a thick wing with frayed drift and a cutting-edge, ultra-modern design. It was 23-year-old Cousinet's first aeroplane, built while he served as an officer with the 34th Aviation Regiment at the Bourget. The monoplane weighed 16 tons, had a wingspan of more than 27 meters, and could carry enough fuel to travel 10,000 kilometers. It also had a wing loading of 100 kilos per square meter, double that of most other aeroplanes of the time. The proving flight took place on May the 7th. Sadly, the pilot, Maurice Drouin, and mechanic, Monsieur Lannet, were killed 3 months later when the aeroplane crashed on a test flight following modifications to its engines. But Cousinet went on to develop the Cousinet 70, which flew Air France flights across the Atlantic during the 1930s.
And these are just part of a long list. But exciting as they are, they mean nothing to the true goal of aviation unless the experience gained is applied to further the speed, safety, and all-round performance of air transportation.
The 1920s and 30s were decades of experimentation and discovery. Aeronautical breakthroughs set the scene for commercial passenger travel. Helicopter technology moved rotorcraft from the realm of fantasy to reality. Airships demonstrated the potential of lighter-than-air flight, and giant aeroplanes pushed the boundaries of scientific knowledge. Once regarded as lightweight, monoplanes took ascendancy over biplanes as designers experimented with radical new structures and materials. And metal bodies replaced fabric and wood, providing strength and endurance and opening the door to a new era. In only 2 decades, the aeroplane had gone from being a novelty to an indispensable part of modern life. People expected reliable goods and mail delivered by air. They eagerly took up opportunities to visit far-flung parts of the globe. Commercial passenger travel was on the cusp of becoming an integral part of the world economy.